Okay, welcome back. In this segment, we're going to be looking at how we can use the GRASP method to solve problems involving uniform motion. So if you remember, uniform motion is motion where an object's motion or velocity is constant. And when we look at this on a position time graph, we've got a nice straight line. Remember, the slope of this represents velocity, so you get a nice constant slope. And to find the slope, we find the change in position over the change in time. So that's going to give us our velocity. So velocity is the displacement over time. That's our first equation that we're going to be looking at. Now remember, velocity is measured in meters per second, standard units. My displacement should be in meters, standard units again, and so is time in seconds. One thing to keep in mind here is that this equation can only be used when there's no acceleration. Okay, so in this case, there's no change in motion, acceleration is 0. So no acceleration. You can only use this with uniform motion. So only use with uniform motion, i.e. when acceleration is 0. If I have an acceleration, I cannot use this equation. It doesn't work, so be careful. So let's look at an example of using this particular equation. So in this case, we've got a courier that's traveling 15 kilometers south, 4 kilometers north, at a constant velocity, and the entire run required 1.7 hours. So I've got my time. And it looks like I've got 2 displacements because I traveled south and then I traveled north. So I'm going to number these, 1 and 2. So let's write down what we know about the situation. Now here, I'm going to write down, the first thing we do is going to write down the positive direction. So I started moving south, so I'll use that as my positive. So south is positive. And I'm going to write down our given. So here's one thing I am going to do is I'm going to figure out the resultant displacement, the overall displacement, because I really need to have that for this particular question. So that's equal to these two added together. So it's going to be 15 kilometers south plus 4 kilometers north. Now, one thing to keep in mind, we did define that south was positive, so this is a little redundant here. We could have just written this down as 15 kilometers with a positive in front, and instead of north, we could have written down negative south. So I'll put negative 4 kilometers. You add this together, the overall displacement for this trip was 11 kilometers. Because it's positive, it went to the south. So we've got the first part of the given. Now the time was 1.7 hours. So in both situations here, we have to convert to standard units. You have non-standard units. So the 11 kilometers is easy to convert. It's going to be 11,000 meters south. And the time, the way to do that is to take the 1.7 and use the factor label technique. You don't have to show your work, but basically we know that there's 3,600 seconds in an hour. So you multiply that through. So let's see that 3,600 times 1.7, and we end up with 6,120 seconds. So those are my givens. What I'm trying to find in this particular situation is the average velocity. So I'm going to write down V average, question mark. I'm trying to find that. And the way to do that is to use this equation. We look at the overall displacement divided by the time, plug our numbers in. So we got 11,000 meters for my displacement over 61.20 seconds for my time. And that's what we get here. So 11,000 divided by 61.20. And we end up with about 1.7 or 1.8 meters per second. That's positive value we have here. So the next thing we want to do is we want to write down the statement here. So we've got therefore the courier's velocity, and keep the statement nice and short, was, we have a positive, so it's 1.8 meters per second towards the south. And we're done. And let's just double check significant digits. We've got 2, 2, 3, so my least number is 2, and my final answer here is 2. 2 significant digits. And we're done. So let's look at another example. Very similar. The only difference is we're looking for a different quantity. So here I've got a runner, and I want to know how long, so the time, oops. So I want the time it's going to take the runner to complete a marathon that long, so it's my displacement, with this velocity. There's my average velocity. So let's write down our givens. So I'm not going to write down GRASP. I'm just going to write down quantities using the appropriate format. So in the given, the first thing I want to do is I want to define my positive direction. I don't have a direction here. So I'm just going to assume forward is going to be positive. There's my positive direction. So the first quantity we have is my displacement. So I'm going to be traveling at a displacement of 42.195 kilometers. Changing it to standard units, we're going to have 42,195 meters. And we've got a velocity of 2.6 meters per second. And we're going to assume that the velocity was constant during this entire trip. And we want to figure out the time. So how long does it take to do this? So the equation we're using, it's a constant velocity. Use the constant velocity equation. So the displacement, oops, over my time. But now I have to rearrange the equation. So I'm going to bring the time over. I'm going to cross multiply. And the time is going to equal my displacement. I'm going to bring the velocity down. And there's my equation. Let's plug our numbers in. So my time is going to equal my displacement, 42,195 meters forward, all over 2.6 meters per second. Let's see what happens when we plug that into the calculator. So 42,195, 42,195 divided by 2.6. And it looks like we've got here 16,228 seconds. Seems like a bit, but remember that's in seconds. So here's what we're going to do. We're going to take a look at the significant digits at the beginning, so we know how many significant digits we need for my final answer. So 1, 2, 3, 4, 5. Here we got 2. My final answer should be 2. So therefore, the runner would require 16,000 seconds to complete the race. All right, let's see how long this will take just for fun in hours. So if I did this in hours divided by 3,600, it's around 4.5 hours. So a really slow marathon runner, probably me if I ever did a marathon. So what we have here, basically, just to recap, is we're using the GRASP method. we're writing down the positive direction, writing down our givens with standard units, writing down what we're trying to find, then the equation, rearranging the equation, substituting our numbers in, and then finally doing a statement with the appropriate number of significant digits, and just paraphrasing what happened here. Now in this case, I don't need a direction because time is a scalar quantity, but sometimes you do need the direction and you must put that into your final answer. And that's it for this intro. The other examples will be posted in class.